Dengar? Semua dengar?
Sudah,
Jelas?
Bapak?
Sudah? Okey, okey.
Sudah.
Oh, izinkan saya sharekan slide saya dulu ya. Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Uh,
Waalaikumsalam.
uh, is it okay if I speak in English? Boleh? Boleh ya? English boleh ya?
Boleh.
Boleh ya?
Okay.
Okay, alright. So first, a very good morning. Assalamualaikum and a very good morning, everyone. First, I want to say thank you to the chairperson for the introduction just now. And thank you to University of Muhammadiyah Pontianak for inviting me as a guest speaker to give a talk related to sustainability in chemistry. So, I'm chemist Dr. Nur Arif bin Murtaza, and I'm a new lecturer for the Faculty of Agro-Technology and Applied Sciences, ICATS University College. And my expertise is mainly in organic chemistry. I've been joining ICATS, actually, it's been around 4 months only, so I'm a new lecturer. I'm actually a new lecturer. So if I cannot say that I'm a real expert in sustainability related to educational chemistry. So today my talk will be mainly on how we can apply sustainability in our research. And also at the end, I will also add on how we can integrate a bit on how sustainability can be integrated in educational chemistry. A brief introduction about my university college. So ICATS was first established in May 2006, and on 2020 it was elevated to University College. And now our goal is we want to achieve a full-fledged university and to become a more sustainable campus university. In our faculty, we have around 7 faculty. Faculty of Multidisciplinary, Faculty of Computing, Faculty of Agro-Technology, my faculty, Faculty of Engineering, Tourism, Economic, and also Faculty of Education and Business. So all these faculty are important because they can contribute to sustainability. Because as we know, there are 3 main pillars of sustainability, which is first, environment, second, social, third is business. So all of this faculty is related to all the 3 pillars in sustainability. So ICATS is very committed to contributing to the SDG goals. We have our own Act for SDG mission. So quote by our acting Prof. VC, Professor Dato' Shazali right now, we strive towards achieving the SDG by creating a sustainable campus and community that inspires everyone to engage in global sustainability effort through balance and holistic practice. So in our campus, we try to train our students to become more sustainable. We create a program, event, or short courses which are related to sustainability. And we even collaborate with community where we teach them how to apply sustainability in their daily life. So why sustainability is important? So based on the definition, sustainability is the ability for us to exist and develop without depleting natural resources for the future, for our future generation. So it is important because we need to assume that our resources is very limited. It is very finite. So right now we consume a lot of, we use a lot of fossil fuel. And if we do not apply a sustainable method in our approach, what happens is in the future, our fossil fuel will become, we will be likely to become, we will run out of this fossil fuel. and also it will affect our environment. Mostly all of our flora and fauna will be extinct, and also our environment, our atmosphere will be polluted. So stated by the UN Secretary General, at a time when the world faces a global pandemic and other formidable threats, we must join focus across border and generation to work together for a better common future. So we, as a human in this society, we need to work together. We need to work together to protect our natural resources so that our future generation able to experience what we are having today. So if we talk about sustainability in chemistry, one of the best discovery that it can illustrate sustainability in chemistry is the discovery of Haber process. So this was first developed by Fritz Haber. Using Haber process, we're able to produce our own ammonia, which is one of the starting material to produce fertilizer. Using this process, we're able to synthesize ammonia using nitrogen gas from our atmosphere and react with hydrogen gas. And before the discovery of this ammonia, human mainly rely on the use of guano or animal manure to use to process to become fertilizer, which be used in agriculture process. So this discovery of Haber process actually have helped us to overcome world hunger. In fact, I think in Sarawak, we have one of the largest ammonia and fertilizer manufacturing in Southeast Asia. In the future, our government, the Sarawak government, planning to manufacture their own ammonia. And this development of new ammonia industry will contribute to SDG 1, which is related to zero poverty, because new industry provide new working opportunity. So, sustainable chemistry or green chemistry can be defined as the design of chemical product and process that reduce or eliminate the use of generation of waste. So our United Nations have stated 10 objectives which is related to sustainable chemistry. For example, we have minimize of chemical hazard, avoiding regrettable substitution and alternative, sustainable sourcing of resources and feedstock, and many more. And this objective is not only applied in industry, we can also apply it in our educational system, because we want to prepare our future generation to be more sustainable when applying their knowledge in industry and also in the working environment. So if you look at this 17 SDG goal, so actually chemistry have contributed to more than half of this SDG goal. For example, just now, no poverty, SDG 1, no poverty, where the development of chemistry-related industry provide a working opportunity to our community. So, contribute to SDG 1. SDG 2 just now, zero hunger, which is related to the ammonia. We can use ammonia as an example. SDG 3, where we use chemistry to synthesize a drug to fight against diseases, improve the life quality and quality in education. For example, us as a researcher, as an educator, where we conduct some research which can help to contribute to advance in knowledge, also help to contribute in SDG 4. Affordable and clean energy, SDG 7, which is where chemistry can work together with, for example, engineering to produce semiconductor or to produce a more efficient solar panel. Climate change, we use chemistry to develop carbon capture technology to reduce the carbon footprint in our atmosphere. And then by applying sustainable chemistry or other sciences, we're able to preserve our environment, which is related to SDG 14 and also SDG 15. So, and then chemistry. Chemistry is a branch, a core part of science field where we study the property, the behavior, the composition of matter. So it is considered a core of science because if you look, everything around us consists of matter, from living things to non-living things. So everything consists of matter. And chemistry can be categorized into different branches. So some of it is physical chemistry, inorganic chemistry, organic chemistry, analytical chemistry, biochemistry, and also computational chemistry, and many more. Actually, there are many more. And each branches of chemistry have their own focus of study. For example, physical chemistry, where we study on they focus on the physical property or behavior of a substance in a reaction. Inorganic chemistry, where study involve mainly heavy metal. Biochemistry, where we use chemistry to understand the process on biological living things. And organic chemistry, my field of expertise, where we focus on studying the compound containing CH, carbon and hydrogen atom. And this organic chemistry actually considered one of the important branches of chemistry, because if you look, everything around us consists of carbon and hydrogen. So it is also called chemistry of life. Our plant consists of carbon and hydrogen. Our fossil fuel consists of hydrogen and carbon and hydrogen. Even our favorite drugs, the sugar, consists of carbon and hydrogen. Even our cell, the cell in our human body, consists of carbon and hydrogen. So during my research, we work as a team. We work as a group. We have a research group, and we try to relate sustainability in our research. So our group, we mainly focus on drug development, where we try to produce our own bioactive compound instead of extracting from nature. And we waste transformation, where we want to convert agricultural waste product into usable product. Innovation, where we create a new technology. For example, we want to create a new green technology to replace all the old technology. And also synthesis method, where we want to optimize our chemical reaction, because we want to search for a method or a process which can produce more product, less waste, less waste management. And also we want to optimize for our reaction to be more, how to say, more energy efficient. So this is our all the our core of research project. So all of this research actually it contribute to sustainability, because a research doesn't have to be very noble. It doesn't have to be a high impact research. Even a small mini research which can help to advance our knowledge in science is considered contributing to SDG. Just now, SDG 4, quality in education. So during my research, this is one of my our research, where we try to search for bioactive compound instead of extracting from nature. So one of our paper published in Natural Product Research, where we able to synthesize a derivative of natural product which have shown a good biological activity. So instead of extracting from nature, we synthesize it ourselves. And this compound have shown good biological activity and have potential to be applied as medicinal drug. However, to process from this stage to another stage, we need interdisciplinary collaboration, because we chemists, we need to work together with, for example, medicinal science, so that our compound can be applied as medicinal drug. So if you compare the use of synthetic drug and also compare it with extraction using a naturally derived compound, synthesizing our compound are more sustainable. If you look at the traditional method where we extract from nature, traditional method is more, how do you say, it is more time consuming, and also it is very tedious. So it is less sustainable to extract a compound. For example, here, salicylic acid is an example of compound that found in willow trees. And this salicylic acid is a bioactive compound that have been used in a lot of our cosmetic product, and also to be used as anti-inflammatory drugs. So to obtain this compound, instead of extracting from nature, we synthesize it ourselves, because by synthesizing, we're able to preserve our nature and reduce the reliance on natural resources. So several advantages in terms of synthetic drug is we're able to preserve our natural resources just now. We can effectively use our resources. We can reduce negative environmental impact, and also we can have a stable supply chain. And another part of my research where we involve in synthesis method. So we want to optimize our synthesis method. So how does optimization in synthesis method relate to sustainability? So as reported in this paper, our paper, we apply green technology compared to the old reflux heating method. So microwave assisted and conventional synthesis of halogenated common azo derivative. So by using microwave and compare it with conventional reflux heating method, we can observe that our reaction is more efficient. For example, here, the yield of our product using microwave is quite high. So higher yield means less waste production. So this side product can be very harmful when we dispose it into our nature. And in terms of energy efficiency, the use of microwave is more energy efficient. If you compare the use of microwave and reflux method, from 6 hours, we can reduce it in to 6 minutes. So here, in terms of energy efficiency, it is more efficient compared to the old reflux method. So the advantages of microwave heating when you compare to with the reflux heating method, so it is more, the microwave can reduce our reaction time and provide high yield of product. How is this possible? Because the use of microwave, we able easily achieve the minimum activation energy, which is required for complete conversion of reactant to product. And also, microwave is energy efficient because using microwave here, microwave using, we call it dielectric heating method. So means the heat energy is directly transferred into our reaction. So less heat loss to the surrounding when you compare to the reflux method. If you look at the reflux method, the heat transfer from example heat source transfer to the we call this container, glass container, and then transfer to the oil beaker and then our reaction. So many heat loss happens there. So it is less sustainable. And third is milder reaction condition, because using microwave, we're able to increase the temperature of our reaction, and we're able to easily achieve the minimum energy of reaction. We reduce our reliance on catalyst. So microwave heating or other green technology is more sustainable compared to the old reflux heating method. So another part of our project where we try to develop sustainable innovation. So this is a part of our research where we try to develop new green technology. So in this paper, we reported on the synthesis of organic compound which have liquid crystal property. And this compound have potential to be applied in liquid crystal display in our monitor, in our phone, and etc. And also it have the property or the ability to be applied in optical storage device. So if you observe, this is the compound. When we introduce heat, what happens is the compound will convert into liquid and then arrange itself to become crystal. So liquid crystal technology. And here we have successfully patented our compound just now, and our compound have received gold award in recent sustainability related exhibition. And also we have patented and won a gold award, and I want to show you a few video. This is our technology. So to achieve this, we need collaboration. So we as a chemist, we do the chemistry part where we synthesize, and then for the application of the technology, we work together with international university. So this is Guru Murthy from India. So if you look, that is our compound being tested for liquid crystal application. And when he bent the frame, what happened is our compound is still maintaining its liquid crystal structure. Okay. Okay, and then another most popular, most famous type of research where we convert waste product into useful product. So in Malaysia and Indonesia, we have you call it a large scale of agriculture industry. So this agriculture industry will produce tons of agriculture waste. So we as a chemist we want to make sure our environment is sustainable. We want to sustain our environment. What happen is we convert the waste into useful product. For example, here we convert a sago sludge into carbon nanoparticle, and this carbon nanoparticle have the ability to absorb heavy metal in aqueous solution. So all this research is related to SDG. So when you conduct research, we are indirectly contributing to SDG, the SDG goal. So so all this talk about research. So we as an educator in higher learning institution, we are responsible to educate our student. Because we want to prepare our future chemists or future generation to tackle global challenges such as pollution, resource depletion, and climate change. So it is our responsibility. We have to provide understanding in chemical principle, and also we need to install responsibility in our student towards creating a sustainable future. So how can we achieve this? By integrating sustainability in our learning material. And based on the UN Sustainable Development Goal, in chemistry, they have provide 14 ways based on the 14 ways on how we can integrate sustainability in our educational chemistry. So let me share a bit. Let me open the. So, okay. So if you look here, they have provide all the ways on how we can integrate sustainability in our education. However, what we have to do right now is we need to focus on one only. So choose one way which is related to our field of expertise. For example, just now, my expertise is in organic chemistry. So I will focus on these several key aspects only, which is green chemistry, sustainable lab practices, and relate all this theory and practical with real world application, and also interdisciplinary collaboration. Interdisciplinary collaboration is in terms of research, because only chemistry cannot contribute to the development of sustainable society. What happened is we need to collaborate with different field. For example, we want to introduce, for example, we want to conduct research on how to introduce sustainability in our younger generation. We as a chemist, which have vast knowledge in chemistry, we can work together with faculty. For example, faculty from educational field to conduct study on how to increase the understanding of sustainability in our younger generation, and also how to attract them so that they have high interest to continue the study in science related field. And here, so as an organic chemist, these are the four categories that I will be focusing in my education, which is first green solvent. Green solvent, because organic chemistry use a lot of organic reaction, organic solvent, organic chemicals. So we try to apply green solvent to replace the traditional organic solvent. And second, we can teach about atom economy, where we can maximizing product and we can minimize our waste product. And third, catalyst. We can teach our student how to develop catalyst. For example, just now, waste transformation. We convert waste into carbon nanoparticle or biochar. We can use that biochar to produce a heterogeneous catalyst. And then in terms of energy efficiency just now, where we introduce microwave or green technology or ultrasonic in our reaction. And then all this, we need to relate it with a real life application. So this is based on sustainability, chemistry, teaching, laboratory content. So how do we relate everything? How do we relate our theory, our practical with real life sustainability? So for example, here we take the green chemistry theme. So we want to relate it with, for example here, biodegradability. So our laboratory pack must be related to biodegradability. So we focus on synthesis of a biodegradable polymer. And then in our theory, we teach all of different type of polymer, natural polymer, synthetic polymer, biodegradable polymer, and we can teach our student on how to, which functional group responsible for the biodegradable property. So we need to relate everything in terms of energy production also. We can teach all about the different type of solar, how to apply solar with solar energy, for example, and many more. Okay. Oh, all right. So as before I end my presentation, so a bit key point that I want to focus on, which is chemistry plays vital role in creating sustainable future. All research can contribute to sustainability. And third, sustainability in chemistry is rooted in education because we are responsible to teach our younger generation. Thank you. And thank you very much. Thank you for your attention.
Baik, terima kasih kepada Bapak dan Dr. Nur Alimotega atas presentasi yang sangat hebat. Sebelum masuk ke sesi tanya jawab, kita berikan aplaus untuk narasumber kita. Baik, kita lanjut untuk sesi berikutnya, yaitu sesi tanya jawab. Kami persilakan kepada para peserta, baik yang offline maupun yang online melalui Zoom meeting, untuk dapat mengajukan pertanyaan. Kami persilakan kepada Bapak Risma Hardian.
Thank you very much, everyone, for I have a motivation for the presentation today. I would like to ask Bapak, maybe I should start with Bapak speaking. Dalam pertanyaan kami terkait dengan belum dilakukan terkait dengan kami proses ini kita akan maksudnya kalau kami ini masukkan dalam itu lingkungan ini kira-kira muatan-muatan for Ali, thank you very much for the information very valuable for Indonesia. About information that in effect we have a sustainable method. I would like to what is what do we mean with sustainable? Because in what aspect the sustainability is applied on campus? You said that you are already the
Kurang jelas.
uh, Coba kita sini Pak. Uh, for Mr. Nur Arif,
Yeah.
I would like to ask about previously you mentioned about the sustainable campus that's already
Yes.
applied in ICATS. I would like to
Yes.
ask what aspect of sustainability that is applied there to attain the sustainable campus. Is it any treatment, any regulation that is applied to the student or to teachers in terms of doing teaching or doing some research there? Is that help you can elaborate more about it? And
Okay.
then one more questions is about in our university, our research is for organic chemistry. We mostly focus on using a natural resource and then to extract it, and then instead of using a synthesis like what you already done in your laboratory. I want to hear your opinions whether it is better to make a balance that we can still explore the natural resource, but we also balance it with a good sustainable approach. And I hope that you can explain that your opinion about it. Thank you.
Okay. Okay.
Uh,
Let me answer the second question first, which related to extraction. So actually, we cannot deny that the main sources of all the drugs is from nature. So from nature. So when we focus on, so we can also be sustainable in sustainable chemistry when we apply extraction. For example, you try to use a less hazardous chemical, and also we try to improve the method. For example, we try to introduce technology just now, microwave technology, because microwave just now can also be used in extraction process. The technology just now is also can be used in extraction process, because usually the problem in extraction is it produce a very low yield of product. So that's the problem. So if you want to so how can we balance it? So we extract it from nature, and then we conduct study on the molecular structure, the structure of the compound. And then once we understand the structure of the compound, we can synthesize it ourselves using organic synthesis chemistry. So that is how we can balance it. So instead of we need a large amount of sample to conduct study, and we want to further apply it in real world application. So we just extract, study on this chemical structure, and then once we open the structure, we try to synthesize it. So that is more in terms of sustainable. So that is more sustainable. Okay. And then for your first question just now, how do we achieve the sustainable campus, right? So there are no rule. I mean, there are no, how you say? Actually, that is our vision to become to become a sustainable campus. So we try to teach our student why to implement all the ethic or all the knowledge related to sustainability in our campus. For example, we as a lecturer, we reduce our reliance on paper. So for paper, we only use it in our final examination. For other documentation, we try to use a soft copy document instead. All the document we use soft copy. Only important document we use hard copy. So there we have already contribute to sustainability. And then we try to involve ourselves in a lot of sustainability related aspect. For example, just now uh, we we have a lot of programs such as we stop we ask our student to use less plastic. That is one of the way on how we want to achieve a sustainable campus. But to become a fully sustainable campus is quite hard. We need to know it is quite hard. So we can try slowly. We can try it slowly to achieve that sustainability campus. I hope that answer your question.
Baik, terima kasih kepada ya. Baik, terima kasih kepada Bapak Dr. Nur Arif. Kita masuk ke pertanyaan yang pertama tadi yang ditujukan untuk Bapak Dr. Suiknya. Halo Bapak. Baik. Saya ulangi pertanyaannya.
Ya.
Baik. Untuk peran universitas, jika kami akan melakukan akan memasukkan ke dalam kurikulum, jadi sekiranya muatan apa saja yang harus ada untuk membantu mengatasi isu-isu yang telah disebutkan pada saat presentasi tadi. Baik, kami persilakan Bapak.
Baik, terima kasih Bu Moderator. Baik, kalau yang kami lakukan memang itu di level pendidikan dasar, kemudian pendidikan menengah. Pengalaman yang kami lakukan itu di SD, SMP, dan juga di SLTA. Nah, ini kami terutama ada 3 pendekatan sebenarnya. Ada yang pertama yang mata pelajaran berdiri sendiri. Itu ada yang di Kaburaya, itu khusus pembelajaran yang namanya pendekatan berdiri sendiri. Yang kedua, ada yang terintegrasi ke dalam mata pelajaran. Nah, Kuburaya juga seperti itu, terintegrasi ke mata pelajaran itu tentang gambut dan mangrove. Ada yang berbasis kepada kurikulum merdeka, itu namanya berbasis proyek P5, gitu. Kira-kira itu yang kami lakukan di beberapa tempat, baik di Jambi tentang gambut, di Riau itu gambut dan mangrove, dan sekarang Kalimantan Selatan kami akan berdekatan gambut juga dan mangrove berbasis P5, berbasis proyek. Nah, oleh karena itu kalau ke perguruan tinggi ini kami memang belum begitu paham, tapi saya kira sama itu. Apakah mau ada yang berbasis proyek, ada, atau berbasis kepada pelajaran tertentu. Nah, kalau pelajaran tertentu berarti ada tema-tema kan gitu ya. Kalau kami memang ada gambut, ada mangrove. Nah, kemudian bisa juga mempelajari kan yang penting kan anak mahasiswa itu kan belajar ya. Ada yang KKN, bisa KKN tematik, itu juga bisa KKN tematik, nanti masuk ke lingkungan, yang tema-tema lingkungan seperti itu. Itu juga mereka akan mendapatkan pembelajaran. Itu kira-kira ininya. Tema-temanya cukup banyak nih. Kalau kami ya tentu saja ada yang gambut, ada yang mangrove, dan sebagainya. Dan ada tema sosial, bahkan kami juga menerima mahasiswa KKN di RGM itu, ada yang aspek sosial kelembagaannya. Masuk ke desa-desa, kelembagaan, atau masuk ke perilaku, pelatihan SDM tadi, ada mahasiswa KKN itu khusus terkait dengan sekolah lapang, gambut, dan sebagainya. Dan sebagainya itu kira-kira metode pembelajarannya begitu. Nah, temanya silahkan ya untuk sustainability itu. Kalau pendidikan kimia ya berarti mungkin yang terkait ya di perguruan tinggi seperti apa. Mungkin seperti itu kira-kira anunya, insight-nya. Demikian, Bu Moderator. Terima kasih.
Baik, terima kasih Bapak atas jawabannya. Baik, kita buka untuk pertanyaan sesi kedua. Kami persilakan baik peserta yang hadir di ruangan maupun yang mengikuti secara online melalui Zoom meeting. Mungkin Bapak Ibu yang di sini. Baik, kami persilakan kepada Ibu Dr. Dinia Hadianti.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Saya ingin mengajukan pertanyaan pertama kepada Pak Suwikna. Kalau untuk di Kalimantan Barat sendiri, sebenarnya yang jadi permasalahan untuk terutama di daerah Kuburaya itu ada beberapa lahan yang sudah dikonversikan atau mau dijadikan perkebunan kelapa sawit begitu, Pak. Nah, untuk di daerah-daerah hulu seperti Kalimantan Barat, yang daerah hulu itu Kapas Hulu, Sintang dan seterusnya, memang banyak yang sudah dikonversikan gitu. Bukan di sana memang nggak banyak mangrove, tapi lahan pertaniannya itu ditanami tanaman sawit seperti itu. Nah, sedangkan di satu sisi kan sebenarnya kita punya program dari Kementerian SDM itu untuk mengkonversikan CPO itu salah satunya menjadi energi, misalnya ada B30 atau B40 seperti itu. Nah, mungkin gimana caranya supaya kita bisa saling berjalan beriringan gitu, entah itu dari SDM, kemudian dari untuk restorasi gambut sendiri, supaya sebenarnya kan untuk yang konversi energi ini kan fungsinya juga untuk menangani masalah krisis energi yang terjadi di Indonesia juga kan salah satunya. Kemudian tapi di sisi lain kita nggak merusak untuk mangrove-nya seperti itu. Nah, mungkin nanti bisa dieksplorasi gitu kira-kira apa yang harus kami lakukan, dan istilahnya ketika kami mengajarkan kepada mahasiswa kami juga, karena kebetulan saya mengampu mata kuliah kimia lingkungan juga seperti itu, Pak. Kemarin kami sempat kuliah lapangan ke ini Merada 2 yang jadi salah satu desa dari mitra dari iCloud seperti itu. Nah, jadi di sana masih diusahakan untuk daerah-daerah mangrove itu memang dipertahankan untuk tidak dikonversikan menjadi sawit seperti itu. Terus yang kedua kepada Dr. Nur Arif, sebenarnya saya juga adalah salah satu riset saya, kajiannya itu di bidang kimia organik, especially natural product. But seperti yang sudah dijelaskan tadi, mungkin memang salah satu yang menjadi kendala dalam ekstraksi atau misalnya natural product itu adalah pelarut atau solvent yang sangat banyak kita gunakan gitu. Namun sebenarnya kita punya riset mapping gitu dari our government, yaitu RIN seperti itu, rencana riset bagaimana mengembangkan tanaman lokal untuk dijadikan obat herbal terstandar gitu. Nah, beberapa riset yang dari Indonesia sendiri itu banyak melakukan ekstraksi tapi menggunakan pendekatan metabolomik. Nah, mungkin bisa di-share kayak gitu, kira-kira apakah metabolomik ini juga bisa mengurangi penggunaan pelarut tadi yang berlebihan, karena memang untuk mengekstraksi satu bahan itu kan butuh beberapa liter seperti itu. Dan terakhir, harapan saya bisa dapat melakukan joint research bersama Dr. Nur ke depannya, karena sama-sama di bidang kimia organik. Harapannya kerjasama antara Prodi Pendidikan Kimia dengan ICAP dapat berlanjut seperti itu. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih kepada ini. Baik, kita mungkin langsung satu lagi pertanyaan dari Bu Nova Kurnia. Kami persilakan.
Baik, terima kasih atas waktunya. Izin, saya Nova dari Universitas Pendidikan Mandalika, Lombok. Gitu. Terkait dengan sustainability, kalau di tempat kami, ya, jadi sustainability ini sangat ideal ya. Kalau kami di dunia kependidikan, itu sangat ideal sekali terkait dengan ide-ide maupun harapan ke depan. Akan tetapi ide dan harapan ini selalu kalah ya dengan kepentingan-kepentingan terkait dengan pembangunan yang begitu masif. Sebagai contoh, daerah kami itu sekarang mulai jor-joran di dunia pariwisata ya. Meskipun mulai digalakkan yang namanya ekoturism. Akan tetapi ternyata dengan tumbuhnya ekoturism ini, artinya ekowisata yang mempertahankan beberapa ekosistem, akan tetapi di satu sisi juga menimbulkan masalah seperti itu. Misalnya pembukaan villa di bukit-bukit, kemudian beberapa lahan mangrove ternyata di daerah kami itu sudah mulai menipis karena memang pembangunan ekowisata itu ternyata tidak berjalan ideal seperti itu, sehingga terkesan tidak sesuai dengan harapan kami ya. Eh, ini yang kita perlu concern terkait dengan bagaimana visi dari pemerintah itu sendiri, bahwa terkadang idealnya pendidik itu kalau seorang guru maupun dosen ingin mengajar sustainability yang ideal, tetapi selalu kalah dengan tanda tangan pembangunan seperti itu. Mungkin itu sedikit diskusi ya. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih kepada Bapak Nurfatul ya. Baik, kita langsung persilakan saja untuk Bapak Switnya.
Baik, maaf, baik, terima kasih. Apakah suara saya terdengar ya?
Terdengar Bapak?
Terdengar, Pak.
Oke, oke, ya, ya. Baik, coba barangkali poin pentingnya apa ya? Diulangi lagi, ada kendala sinyal di tempat saya, coba sebentar. Ada.
Pertanyaan yang pertama tentang lahan yang untuk kelapa sawit ini Bapak, terkait dengan proses CPO. Jadi bagaimana untuk cara BRGM di sini untuk bisa menselaraskannya antara konversi energi.
Ya, baik, itu aja ya. Baik, saya kira kalau BRGM itu memang lebih fokus kepada namanya, kalau ini kan di gambut ya, gambut itu namanya restorasi gambut, sehingga memang kami lebih kepada bagaimana melakukan upaya pemulihan lingkungan gambut yang rusak. Dan kami lebih difokuskan lagi di luar kawasan ini untuk gambut. Nah, memang problem kelapa sawit ini salah satu yang ini ya, sehingga kami lebih fokus kepada bagaimana memulihkan gambutnya itu yang rusak. Namun kami di dalam mengantisipasi terhadap keberlanjutan ini adalah kami menggunakan pendekatan SDM, di mana SDM itu kita latih agar di dalam memanfaatkan gambut itu adalah ramah lingkungan. Itu yang kami coba. Sehingga mereka yang biasanya bertani di gambut itu kan menggunakan api ya untuk penyiapan lahan, itu kemudian di dalam sekolah lapang itu kami latih untuk tidak menggunakan api. Nah, kemudian yang berikutnya menggunakan beberapa namanya nutrisi tanaman alami yang berbagai pupuk-pupuk buatan secara alami. Itu kira-kira yang pengenalan kami seperti itu. Nah, masalah energi memang kalau gambut itu salah satu contoh pernah dijadikan energi, tapi di luar negeri itu salah satu yang kami tahu di Finland itu gambut malah ditambang untuk bahan bakar, begitu seperti itu. Nah, itu yang terjadi. Nah, kalau di Indonesia memang belum ada sih gitu. Jadi kalau konteks seperti itu kayaknya memang kami belum pernah sampai ini mengintervensi sampai kepada misalnya sawit dan sebagainya. Maaf, mungkin kira-kira gitu gambarannya. Terima kasih.
Baik, terima kasih Bapak. Mungkin kita lanjut ke pertanyaan yang ketiga dari mengenai bagaimana peran pemerintah ini terkait dengan ini tantangan antara pembangunan dengan proses sustainability ini.
Oke, baik. Bisa menambahkan Bu moderator?
Ya, gimana Bapak?
Bisa menambahkan sedikit?
Siap.
Oke, baik. Kalau kita dengan aspek pembangunan dan sustainability, itu tadi saya sampaikan di dalam slide, salah satu slide, di mana di dalam proses pembangunan itu kami kan ada contoh yang untuk mangrove ya, mangrove itu kan ada pendekatan teknis rehabilitasi mangrove. Ya, mangrove itu artinya menanam. Di mana mangrove-nya sudah rusak, kita melakukan upaya-upaya pemulihan. Mangrove yang masih bagus diupayakan dipertahankan, kan itu kan menanam aspeknya ya. Nah, kemudian untuk menjamin sustainability, maka kami menggunakan pendekatan penguat. Nah, pertama gini, ada pendekatan sosial namanya. Paling tidak di awal itu kami menggunakan namanya prakondisi sosial sebelum menanam. Prakondisi sosial itu harapannya adalah ada komunikasi dan prakondisi sosial untuk kesiapan masyarakat yang akan melakukan penanaman mangrove gitu ya. Selain itu juga ada pendekatan kelembagaan ini, kelembagaan desa itu. Ada penguatan kelembagaan kelompok, kelembagaan desa. Di mana kelembagaan desa itu dengan intervensi berupa agar desa itu punya peraturan melindungi lingkungannya. Nah, ini seperti ini cukup efektif juga. Dan juga agar dalam perencanaan desa itu juga turut mengagendakan terkait dengan kegiatan rehabilitasi mangrove, misalnya pemberdayaan masyarakat dan sebagainya, sebagai salah satu agenda pembangunan desa. Itu kira-kira intervensi desa. Intervensi SDM. Nah, SDM-nya juga kita lakukan perubahan perilaku. Bapak Ibu sekalian, di dalam pembangunan rehabilitasi mangrove itu, masyarakat itu gini posisinya. Belum begitu menyadari bahwa mangrove itu penting untuk kehidupan. Nah, tadi kan ada data di mana 700-an ribu hektar itu mangrove menjadi tambak. Nah, padahal dulu mangrove, ya kan, begitu menjadi tambak, mau ditanamin mangrove lagi, kemudian timbul problem. Masyarakatnya nggak mau ditanamin mangrove. Nah, kira-kira sehingga ada upaya perubahan perilaku SDM agar mereka bahwa apa yang dipunyai ini tambak kemudian diramah mangrove kan, tanamin mangrove itu bisa menambah penghidupan gitulah, itulah kira-kira itu upaya-upaya SDM. Nah, dari berbagai upaya itu kita berharap muncul namanya isu sustainability. Aspek sustainability itu adalah yang sifatnya nature atau alam, sustainable ya mangrove-nya, dan juga aspek makanya sustainable, ekonominya sustainable gitu kira-kira. Sehingga sustainable itu skop yang cukup kompleks, tapi memang tidak bisa satu pendekatan gitu kira-kira gitu. Baik, terima kasih.
Baik, terima kasih Pak Sujud atas penjelasannya. Baik, ini kami persilakan untuk Bapak Dr. Nur Arif. Untuk pertanyaan dari Bu Dini terkait kendala untuk penggunaan pelarut pada saat proses ekstraksi. Jadi mohon bisa berbagi tentang penggunaan pelarut terkait proses ekstraksi.
Berkaitan dengan the use of organic solvent for extraction.
Organic solvent.
Because I have no deep knowledge in extraction, because my expertise is mainly in synthesis. So just now you mentioned about what do you call metabolite, right?
Yeah, metabolic.
Metabolite. So actually the term is very new to me. So actually we cannot deny the fact that extraction process requires a lot of the use of how do you say, the use of organic solvent. So what we can do is instead of using extraction to produce the compound, why don't we synthesize it ourselves? Because once you extract, right, we study the structure just now. We study the structure of the compound, and then once we know this structure, we use our chemistry knowledge. We can create a method on how to synthesize the compound. But again, there are some compounds that cannot be synthesized. For example, just now maybe morphine. Morphine is one of the mostly use drug as painkiller. So right now, how do we produce morphine is still through extraction because of the complex structure of the compound. So we unable to synthesize it. So there are no alternative way other than extraction. But for just now, it is important to the structure of the compound. I hope that answered the question. So maybe in terms of collaboration just now, maybe we can discuss more in detail so we can collaborate.
Yeah.
So saya ada
Yeah.
ada juga lah.
Because in here we have limited instrument for identification of the structure, so we can collaborate with next research projects about the natural product as drugs.
Boleh, boleh.
Thank you so much.
Okay, thank you, Mr. Nur Arif. One more question, I think. Yeah, one more question from Ibu Husna Amalia Melati. How can we ensure that energy efficiency can be improved when using microwave irradiation compared to conventional heating from an economic perspective? Is there data available that can be referenced as confirmation of energy efficiency supporting the sustainability development goals?
How can we ensure that energy efficiency can be improved when using microwave? Okay, in terms of energy efficiency here in organic synthesis, we want to reduce the heat loss to surrounding. All the energy that being converted from electrical energy to heat energy direct into our reaction. So we want to reduce by using microwave, the heat energy can be directly transferred into our reaction. Instead of, for example, using reflux, requires long amount of time. So more energy to increase, for example, we want our reaction to achieve 80 degrees Celsius. So more time taken, more energy taken required to increase to achieve that temperature, because reflux method, there are so many heat loss to our surrounding. So for example, using microwave reaction is being conducted in a closed vessel, and we use dielectric heating. So the energy is transferred directly into our reaction. So all the energy is absorbed by the reaction, and our reaction able to achieve the minimum required energy for complete conversion. So in terms of energy efficiency, microwave is more efficient. So but from economic perspective, it's hard for me to answer that part because our study is mainly in small scale study. So I don't really have any experience in applying it in large scale. So in terms of economic perspective, is there data available that can be referenced as confirmation of energy efficiency supporting the sustainability? So, and then maybe I will try to read more, and then I can get back to you on how is there any data which can be as reference related to your question. Okay.
Baik, terima kasih kepada Bapak Nur Arif. Baik, baik kita, oke. Baik, kita cukupi untuk sesi kita pada pagi hari ini. Sebelum saya mengakhiri atau menutup pada sesi ini, akan saya bacakan kesimpulan untuk pemateri yang pertama tentang isu sustainability di Indonesia, yaitu ada dan pendekatan yang utama yang telah dilakukan, yaitu dengan cara mempertahankan salah satunya pemberdayaan masyarakat, kemudian juga pendekatan untuk meningkatkan dan juga memulihkan dilakukan dengan berbagai metode dan juga innovation dan juga transformative policy resource depletion and climate change and also educator response. Baik, demikian kegiatan kita di sesi diskusi yang pertama. Sekali lagi kami ucapkan terima kasih kepada Bapak narasumber, Bapak Sliknya dan Bapak Nur Arif. Baik, sebelum mengakhiri, karena tadi MC ada menggunakan pantun, saya juga ingin berpantun. Siang hari makan kuaci, makan bareng sama Bani. Kita berapresiasi kita hari ini, mohon maaf. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh.
Waalaikumsalam.